responsibility because I was Yusem's first student, okay? So today, my talk will be two parts. The first part just talk some part of contribution for Alfredo Iusem, not academic contribution, because I'm not, how to say, capacity to evaluate his contribution, but he's as a leader of Brazilian continual community, okay? Continual optimization community. So the second part is some short survey talk about numerical linear algebra in the data science, which will be very fashion in the future, okay? So this is my talk. And the first part, so Alfredo Iusem, everyone knows, he was born in 1949. So this year, it was his 17th birthday, okay? So, and when he finished his secondary school, and he didn't know how to choose which area he started his undergrad program, okay? And because he likes mathematics and history. And we know even everything, he knows almost everything. When you talk with him, he can talk every subject for 3 hours without stop, okay? So people told me he will spend 1 month to think about math history. Finally, he decided to study math. The reason is that he thought if he study history, he never can study mathematics again. So if he study math, then he can still study history. So this is why he studied math, okay? This also was my luck, okay? If he studied history, maybe I wouldn't be his student, okay? So, and from 1971 to 1976, after his undergraduate programming, he worked in Argentina. So first he worked in University of Buenos Aires as a math teacher. And then he worked in some national institute. I guess it's like math engineering, right? That's my definition. It's not his definition, okay? And so in 76, because the military government, so he escaped it. I think many Argentina people here, the same situation, okay? Like Mario Martinez. So he went to Mexico to work in the university. And so for several years. Then from 77, he went to Stanford to start his master's degree and PhD degree with Professor George Danzig. So it's my academic grandfather, okay? And then he got his PhD in September, So in 1981 from Stanford University. So then at that time he got an offer from Stanford University and also got an offer from IMPA here. And as he told me, at that time the salary in Brazil and in USA almost the same level. But the living expenses here is much lower than USA. Then this is why he chose in Brazil, is right? So, so Brazil is lucky, okay, after using Brazil. So, then he working from 1981, October, he started working at the IMPA, okay? So, during his career, he has collaborated with many people from many countries and also has many students from many countries, okay? From China, from Iran, okay, from South America. So, and he made a great contribution in the research, several areas, and also as a leadership of optimization community. So he was, coordinator of the projects for many years. He's a very wonderful leader. He has very big heart to union everyone. So support every young students to do research, okay? So he has published 149 research papers. So 8 expository papers and 3 books. Also, so he has directed 14 doctorate theses and 4 master dissertations. Okay, this is his great contribution in academic sense. Because this in 2000, he was elected fellow of Brazilian academic science. So this picture that when he gets the diploma of the fellowship, okay. So, and he was, as I said, so he was one of the principal leaders of Brazilian optimization community for many years. He was coordinator for external core and continued optimization for many years. Today is Solodov, okay? So he passed the responsibility to Solodov. And with our new leader, and he supported many younger researchers in all possible way. So he has very good heart to accept everyone who likes to work on optimization. And unite all people to work together, which is very important for all new generation. So we should support everyone and union all community. This will help the community create to, to develop the contribution. The community will become bigger and bigger. So therefore, since his contribution on continued optimization and development of Brazilian continued optimization community, he was awarded the Order National of Merit Scientific. Okay, so that was 2002. This is one of the highest science premium for the scientific community. So also he was elected fellow of twice, the Third World Academy in 2003, and the Simon Fellow in 2009. So he has several distinguished students, and I'm also very proud for my brothers. One of them is Regina. So he was finished in 1905, and the direction of the Iusem. So today she works in Australia. Unfortunately, he couldn't come this event. Okay. Another smart student is Bernard Zweiter, and so he finished his PhD in 1904. Okay. Also, is a very smart guy. Joined with Iusem, published many papers. So today he was not here. So this is his principal distinguished students. So Iusem is one of my mentors. I have several mentors, okay? And especially here, Nelson Maculan, Martinez, and Clovis, all my mentors, okay? So, and So in 1989, I tried to study my PhD outside of China. So I didn't know Brazil at all at that time. Okay, I just find one address at the IMPA address, and one user's paper with Álvaro de Ribeiro. So then I found the address. I sent the application letters, and after 3 months, I think more than 3 months, I received one letter with Chinese letter. So I was emotional. Oh, this professor can speak Chinese, right? So, and then after arrival, I didn't speak Chinese, but he is very sympathetic, very emotional to me that he worried I couldn't understand the English. So he asked some Chinese students to translate his letter in Chinese, okay? And to help me to understand the situation. So this gave me very good impression. So he considered students' situation. So the funny is that, the Chinese people understand the yes or no. Sometimes it's confusing, okay? So in the application form, there's some place to choose if you want scholarship or not want scholarship. I thought I want the scholarship, okay? I just mark the place. Then, in the letter also, I wrote that I must have scholarship without scholarship, I couldn't come, okay. Then after I arrived here, user told me in the application form, I didn't want scholarship, okay. That means if he didn't correct my application form, I will come without scholarship. Fortunately, because my letter said I need a scholarship, so he corrected my application form. So I really thank him for this correction, okay? And another thing, because that time China had no inflation, okay? And also I couldn't find a book in the library about Brazil, in Chinese library. So I just know two things about Brazil. One is carnival, another is football, nothing more. But I didn't know about inflation, Brazilian inflation, okay? So at the beginning, user wrote a letter to me, so my scholarship is more or less about $800 US. At that time, so $800 US is big money, okay? I was very happy. Then afterwards, several months later, he wrote a letter to me, Yuan, your scholarship is about $500 US. I was strange, why? But he always gave me his expectation. No, it has possibility to increase your scholarship, okay? And the first year I couldn't get permission from our country to leave from China. So then he sent me one letter, very, very good letter. He said, the permission letter, whenever you like, you can come to be our students. So with this letter, I spent 1 year to negotiate with my university to get a passport. Because in China at that time, you cannot resign job without authorization, okay? So the university should agree with your retirement. Otherwise, you cannot resign the job. So I spent a whole year to get something to come here. But the permission is that as a scholarship, visiting scholar, less than 1 year. So Iusem is very, very friendly. He sent me invitation letter as a visiting scholar, only for 11 months. So then with this letter, I got permission to come here. So when I get everything done, and I received his last letter, yeah, your scholarship just $300 US. And he rent apartment is about paying dollar, not pay cruzeiros. At that time it's cruzeiros. The $175 per month, the rent. So I was, I don't know how to treat the situation. I come or don't come. But I have no choice because everything is done from China. So then I have to come. But he all gave me the expectation. No, don't worry. Your scholarship has a chance to increase shortly, okay? So this is good. So this Brazilian style, never lose expectation, never lose hopeless. And during my PhD program, and the user is very friendly to me, we talk almost every day. The most issue we talk is about how to survive in Brazil as a foreigner. Okay? So he has very rich experience in USA, in Brazil, as a foreigner. So he gave me very, very good advices to live here, okay? And so, in fact, I learned a lot from him about the life, about the mathematics, about the research. So the most important thing is that, and where I just came, we have talk, okay? And the funny is that talk at that time, because my English at that time was Chinese accents, and the user's English with Spanish accents. So we couldn't understand each other, okay? I speak my English, he speaks his English. So sometimes we should pick the chopstick to write down the blackboard to understand each other. And so there's a funny story. Once, and in the class, he speaks, today we know, Portuguese, okay? And that's why I think Portuguese, not English. But I couldn't understand any Portuguese at that time. He said next week would be the test. But I didn't know anything. I didn't prepare anything. So the next week, Regina asked me, did you prepare the test? I said, what's the test? She told me, no, today's a test. I don't know. So I couldn't understand anything. That's okay, I just take the test, okay? And then I talked with him. I said, Iusem, you told me in the class you speak English. Why you speak Portuguese? The funny answer from Iusem, so keep me silence. Iusem told me, mathematics is international language, which is independent on any particular language. So I cannot answer anything. I just accept his argument, okay? So then he told me, Yuan, when you leave from China, doesn't matter what you have in China, okay? You have nothing after leave from China, So then you can try everything you want because you have nothing to lose. If you earn, you got what you want. If you lost, you didn't lose anything because you have nothing, okay? So this teaching me in Brazil to try everything. So when I go, after finish my PhD, go to Curitiba, I still try everything because I have nothing to lose. This is why I fight each other to improve the department, to set down many things in our department, okay? So this is very good philosophy for young people, okay? Because you start your career, you have nothing, then you can try. You can have nothing to lose. So with his help, I finally got my PhD degree in December of 1993, and only 2.5 years. So I really thank him, okay? So this is after my defense. That time, Regina, Mauricio, and Benai still studied, but Benai is not a regular PhD student at that time, right? Yeah. I really thank you, Alfredo. Okay. Without you taking me to Brazil, there would be my today. Okay. So this is my appreciation to Alfredo Iusem for his 17th birthday. What's time? Do you have many times? I don't know. 25 minutes, okay. So now I talk about something related to optimization. And this no, in fact, the Brazilian continuous optimization community, Hermanchi, thank for him his contribution. We get a very big development. So he not only has a son, academic son, he also has some academic stepson like Horizon get some help from Iusem. So very big help, okay? And when the conference, all young people talk, he give comments to improve their work. So this is very good. So I think all young people thank him very much. So recently, I was in USA to visit several universities. I meet Gilbert Strang. We talk about fashion area, data science, okay? And I said the numerical linear algebra, it seems not big contribution recently. He said, no, thanks to data science, we have many work to do in the future. So this I decided to talk about numerical linear algebra in data science, okay? So the reason is that most data are stored in the matrices or tensor. So this, when you relate to the matrices, then numerical linear algebra can be applied, okay? So the difficulty is that you have huge size of data, huge size matrices, okay? Much abundant informations, and also errors. This is 3 difficulties make the data science. Of course, there is another thing, data science is less information, okay? So, then machine learning and deep learning or reinforcement learning all are based on stochastic optimization techniques and optimization related to subproblem related linear algebra to solve the linear system or to get the eigenvalues. So this is related to numerical linear algebra. So, and yes, I said optimization is very tightly related to the numerical linear algebra, and at least the solution of subproblem at each step, and the matrix decompositions or eigenvalue problems. This is all related to the optimization. So statistics is related to the linear or nonlinear least square techniques. Okay. So the numerical required numerical linear algebra for data science is as follows. First is matrix decomposition. Today, the fashion is tensor decomposition. Okay, the tensor decomposition, that means you just segment the tensor to the matrices. They use the matrices decomposition to approximate tensor decomposition. Least square problem is old technique, old method, but still active. Okay, low rank approximation. This is very common to reduce the size of the matrices. And SVD and eigenvalue problems. This is, of course, it's a very expensive tool, but it's a very useful tool. So the data mining, at least the 3 directions of numerical linear algebra applied to the data mining. Okay, one is information extraction from data matrix by a rank reduction process. This way is used rank approximation, low rank approximation. Okay. So this is based on matrix factorizations. Data compression by low rank approximation for huge data. So from the left or right single vectors, then you can get the rank approximation, low rank approximation. Self-reference definitions that can be formulated mathematically as eigenvalue problem or SVD problems. So this is 3 main directions about the data mining. Okay, the text mining, so extracting useful information from a large unstructured collection of text. So then people use matrix factorizations, long source bidiagonalization, etc., all based on matrix factorization. So lower rank approximation for data expression, in fact, filter dependent upon the information from data matrix. So people use matrix factorization or least square problem. Classification of pattern recognitions. In fact, one application is classification and/or handwriting digitals. So most people use SVD, and of course, it's expensive tool. Okay, so. And the eigenvalue method for data mining, search engine for internet, this is very famous. So the Google search uses the eigenvalue problems, okay? So, and today is a fashion about tensor analysis. I think most people in the American algebra today concentrate on the tensor. In fact, they generalize matrix decomposition to the tensor case, okay? So, but it's an old idea that many years ago just had this idea. So the particular generation SVD, the high order SVD called at the beginning. Today we call the tensor decomposition, but before we called the high order SVD, so HOSVD, okay? So at the beginning, this is Tensor started 2000, okay? So these 2 papers, and those are high order SVD, in fact, Tensor SVD. So this was by the same authors, okay? Then the research survey paper published in the Academy in America is about 2006 by Edo. We call it's called the numerical linear algebra in data mining. Okay. So what recently very very hot is about non-negative matrix decomposition. And this is because many applications, especially for neuroscience, okay? And that means you have non-negative matrix A, you should separate a decomposition for product of two non-negative matrices, M and A. The reason is that for neuroscience, you have non-negative value, or you have zero or positive value, okay? So they must do something to simulate surgeon, okay? So they minimize this optimization problem. So this minimize that, and to find, that means for some way you give the base function and the weight function all free. Then you choose different base function, and you choose different test weight function, such that the approximation is best possible, okay, as good as possible. So this has a long story. At the beginning, the name is self-modeling curve resolution. So it's the beginning of 71. And because, you know, at that time, the real science is not so active, so nobody pay attention, okay? Then, and so, in fact, they sometimes afterwards, mathematics consider about the curve decomposition, they use a positive matrix factorization, okay? This is the name. So this is a continual work, but in fact, didn't cite too much, okay? They called 71s and almost nobody cited those workers. So then 81, 84, then 93, okay? And 83, the all is that, especially linear algebra, the mathematics journal, okay? So continue the people do some work, and so I think in the community, mathematics community not a fashion about the non-negative matrix factorization. So then until 1909, then become very fashion, okay? Especially in engineering, because the two neuroscientists in Johns Hopkins University, they use this to apply to the neuroscience, okay? Then they published a paper in the, how to say, Nature. Then become fashion, okay? The paper was cited many times, and so there are many people, especially data mining, use this method to do, because many data mining issue becomes non-negative matrices, okay? So the non-negative matrix that is this problem, you can write it this way. So that means you have the old iteration. This is iteration system, okay? Maybe here is 0, then it's just some tolerance to guarantee continue works. So, in fact, this algorithm is inexact gradient method. The smart place is that you take out the non-negative restriction. This is a good way, this is a smart way. Okay? Because we know for the non-negative constraint is difficult to do. Then here, he just gets some smart way to take out non-negative restrict constraint, okay? So this is one way. And this, I gave some proof in Clovis workshop in 2004, okay? In Florianopolis. Then, you, for real problem, recently, you can put more restrictions, okay? Regularizations, merit functions, so on, but you should still keep the non-negative restriction free, okay? And also some extension for different applications. There are different extensions. And especially recently, by some application, just one side non-negative matrix decomposition. That means here, so you pick about M non-negative or N is non-negative because the density of the application. So this is just how the new issue, and many younger people is working on this way, find different algorithms and different applications. The first guy to do that is a group for Hanson Park from Minneapolis. Today is Georgia Tech, okay? So, it is a key foundation to the field of machine learning, from rotation used to derive operation of algorithm to implementation algorithm in code. So, and the algebra linear is very, very important tool for the merging things, okay? So, there are many applications. Then I will not go to details here. And the row and the columns, you have some physical meaning, okay? So this is, in fact, I can say, because the data set is very big, from computer science, they have some idea called smart data. That means before you give the data analysis, you still make some filter of data to filter some unuseful data. Sometimes it uses optimization method, okay? So because of you filter data, you can reduce the size of the data, you can save the working space and the memory space. The second case is images and photographies. So then that means you, each picture, you have pixels, then you use matrix from linear algebra to do that, okay? And the second speaker didn't come. He used this way to treat the matrix images, okay? And so he works many years about the matrix images. Today, the people use how to say much modern images. That means resonance, tomography, and X-ray together to fix out the tumor, okay? So one hot code in code, this is some computer science way to, to do data mining, okay? So, and then linear regression, this is statistics way to do. They are also based on the AI decomposition, SVD, so on. So all related to the numerical linear algebra. So regularizations. So this is for optimal community is very famous, not very well. And the people today, because they want how to sparse solution, then put some restriction about L1 norm or L0 norm, okay? So, and this is statics way is a principal component analysis, and in fact, it's equivalent to SVD, okay? So the tool is really SVD, so I will not talk details. So, of course, SVD is very useful, and for the many applications. And we know SVD is very expensive. And so another is latest semantic analysis. So this also is one application related to matrix factorization here, okay? Recommender system. This is very useful in the business way, especially for internet, okay? Then this also related SVD, eigenvalue problems. So you know when you access some website, you always get the advertisement for the product because the system memorized what you are interested in by your access. They sort, they think by the eigenvalue, find you may interested in some product, then it give you, send you the advertisement. Okay. So deep learning, and deep learning is very fashion way today. In USA, almost all people in primary math to do deep learning from different way. And there is a nonlinear function, in fact, deep learning. There's several layer network with nonlinear function. And from optimization point of view, it was estimate parameters, use optimization method. And for the numerical analysis point of view, they think it was approximation of high dimension numerical analysis. Because today, numerical analysis just get 4 dimension. The high dimension, nobody knows how to do. So then the people thought deep learning is somehow approximation, the high dimension numerical analysis. Okay? There's some group work about that, published several papers. They thought that they will set up some systematic theory for such things. Okay. Of course, there is another way about error analysis, because each level you have error, you have to control error. There is self-learning to control error automatically. Okay. So this also based on the matrix rotation. So this is some work recently about numerical linear algebra in the machine learning, okay? Some side papers. And there are several applications in the several areas: astronomy, text mining, spectral data analysis, and internet distance predictions, non-stationary speech delousing, bioinformation, nuclear imaging, so on. There is something I said SVD is very expensive. Then there's similar work about we call the conjugate decomposition. It's similar to the SVD, but is not as expensive as SVD. They don't use eigenvalue, just use how to say the conjugate gradient vectors to construct some decomposition. So then you get some, you release here, sorry. So here, SVD, this is also orthogonal. Here, it releases to the just long singular. You don't need orthogonal. So there, that means you can change the position, okay? Depends the size, depends the position. Then you can get that one here, okay? This was published in these papers. Then, so we did some compression for some applications. So you can compute the generalized inverse, okay? So this is new decomposition as SVD. You compare with the precision is very good, okay? It's compatible to the SVD. And, okay, so these two cases, this is the size problems from the test matrix set. So we got some harmonic estimation to do that. So this is the physical problems. You have the function singular, then you have the things, okay? You have solved the overdeterminate system. You use two ways. We use 3 methods. One is new decomposition, one is SVD, one is FFT, okay? So this is computer time. This is exact solution. This is approximate solution. So you can see that FFT is very fast, but the precision is not as good as SVD and the new decomposition. So if by that one, then the new decomposition is better from our sense, okay? Is very fast. And so this result come from, this problem come from these papers. And so you see the, how to say, the signal. So this is the liquid decomposition, is SVD, SFT. This is totally for the, out of the standard result. So this is similar. So the new decomposition is much cheaper, faster than the SVD, okay? And what I want to say is this decomposition. So far, we didn't finish the main work because for the rank, for rank matrix, it works quite well, okay? But for the rank deficient matrix, because the low space, we cannot find a good way to do that. This is a trouble. The second interesting thing is that this decomposition, this value, like SVD, okay? This value here, For 4-rank case, they have monotonic behavior, or their monotonic increase or monotonic decrease. But theoretically, we cannot prove that. So that means for 4-rank case, you can use this method to do low-rank approximation very fast, very quick. Okay? So this is things. And about applied PhD, I will not talk about that because there's another good phenomenon about this approximation. So, and this is the following people, things we need. And so this is, I think, I repeat, we don't do it. So anything, this is some examples. And there's some words, some software, some library you can access, okay? So then, finally, happy birthday, Alfredo.
Thank you very much.